All right, here we go. This is going to be our last new method of this chapter about graphing quadratics, and we are going to be talking about the factored form of graphing quadratics. So this is what our problems will look like. X is there, there'll be numbers here and here, obviously, maybe. So this is what you need to know when you look here. These numbers are the x-intercepts. And again, notice it's the opposite of what's in parentheses. We touched on that the last couple of days. That's a standard. It's the opposite of what's in parentheses. So I see here the x-intercepts of my parabola are the two numbers here, but it's the opposite of those numbers. Now, because of the symmetry of our parabolas, we know that the axis of symmetry would be halfway between those two. So I can find my axis of symmetry by adding my two intercepts together and dividing by 2. That's what this means. This is how I find my axis of symmetry. I add the two intercepts together and divide by 2. I find half of it. All right? Now, the other thing that you need to know is this point right here, the vertex. The way I would find that vertex is the same way I found it last time I knew axis of symmetry. Once I know the axis of symmetry, I plug it in to find my vertex. All right, so let's roll on from here. Describe the domain and range, but I take a look at this first. So I need it in, as I said in the beginning, factored form. So the way I would roll through a problem like this is I'm going to factor it. All right, we haven't talked about factoring in a little while. What kind of factoring do you always check for first? Okay, GCF. I try to find out what they have in common. I got to do that. So I look here, I see 2 and 8. So 2 is my GCF. That's my first line of factoring. Then I need to factor further. Some of you recognize this as a special case. Some of you probably do not. I told you that these special cases are extremely important and they will pop up a lot. This is where they're popping up. So right here, I'm going to factor that as x minus 2, x plus 2. And then of course, don't forget your number out front. Okay? So now I have this in factored form. What are the intercepts? Well, the opposite of what's in parentheses. So my x-intercept is 2 and negative 2. All right, so now 2 and negative 2. 2, 0, negative 2, 0. There we go. What is the axis of symmetry? So I know my parabola goes here. It could go like that, or it could go like that. I don't know exactly the path that it takes. I just know it goes through these 2 points. All right, so now I've got to find out exactly where this vertex is. In order to find the vertex, I need the axis of symmetry. The axis of symmetry, add the 2 intercepts together and divide by 2. So 2 plus negative 2 is, of course, 0. So my axis of symmetry is 0, which of course I can look at the graph and I can see it's halfway between those 2. So now I plug in 0 back into my original problem. 0 squared times 2. 0 is negative 8. So I know my vertex is like down here at negative 8. I plugged in 0, I got out negative 8. It won't always just be that number out there. All right, so there's my vertex. So the question was domain and range. Domain, we talked about at the beginning, what's the domain here? Yeah. What's the range? So my range lies on up, greater than or equal to negative 8. That vertex tells you your range. This number here will always tell you your range. You just need to figure out if you're going up or going down. All right. So there's a rough way on how you're doing it. You're going to factor. You're gonna find your zeros, your x-intercepts. From there, you're gonna get your axis of symmetry, plug your axis of symmetry in to find your vertex. That's the process we're gonna be going through. All right, so vertex, axis of symmetry, and x-intercept. We don't have to do graph domain origin. So, right here, what is the x-intercepts? What are the x-intercepts? So there they are. -2, 0, and 3, 0. From here, my axis of symmetry. Now I could graph this. I don't have to graph it, I'm just graphing it for you to kind of get a visualization of what's going on. What is my axis of symmetry? Well, how do I find it? Add these two together and divide by 2. So that's 1 over 2, so that's x equals 1/2. Right here is my axis of symmetry. From there, I need to find the vertex. I take this, plug it back in to find my vertex. 1/2 plus 2 is 2.5. 1/2 is -2.5. These numbers will always come out to be the same. They should always come out to be the same with a positive and a negative version. That's going to happen a lot. All right. So I multiply 2.5 times 2.5, -2.5, and that's -6.25. So your vertex is what you plugged in, what you get out. Plugged in 1/2, got out -6.25. There's my vertex. So it's down here somewhere. Let me erase this graph now. Domain. Range. Find this. Is it going up or going down? There you go. Questions? All right. Do number 2 on your own. There's my x-intercepts. Add them together. There's my axis of symmetry. Plug it in. I did something wrong, didn't I? Oh, that's a -4 plus 1.5. I think it's 1.5. I knew it was 1.5. So again, that's going to be -6.25 times -2 is 12.5. So my vertex is 1.5, 12.5. Now, is this curve upward or downward? Yeah, we know from this right here, it is a downward facing curve. Okay, so I could graph this all out if I wanted to, but I know it's going down. So then if I go again, domain is all real, range is this number, and it's going down, so it's less than or equal to 12.5. So there you go. I know my intercepts. From the intercepts, I get the axis of symmetry. From the axis of symmetry, I plug it back into the original and do the math to get my vertex. The vertex is the axis of symmetry and this answer put together. And this answer here tells me my range. All right? We can add one more layer of fun to this. Any questions on this? And give you something you have to factor first. All right, so this is factored already for you, something you have to factor first. What kind of factoring do you check for first? Is there one? Yeah, 4. So I have 4. How's this going to factor? There you go. Okay. Factoring's going to come up a lot here. You got to remember how to factor. What are my intercepts? Axis of symmetry. Plug it back in. That's an easy one. All right. So domain, reals, range. Is this one curved up or curved down? Curved up. So my range greater than or equal to negative 36. All right. So you'll see this word here, zeros. That's referring to the fact that whenever you write an intercept, it's got a 0 for the y. So zeros is the same thing as x-intercepts. So if you see this, find the zeros, that just means find the x-intercepts. So if it wants you to find the zeros, that's real easy. The zeros are 1 and negative 2. There's the 2 zeros. There's 2 of them. All right, that's all there is to it. Just do the opposite of what's in parentheses, and you have your zeros. By the way, side note, if I would have a parentheses, something that factors like this, all right, the reason it's the opposite of what's in parentheses is I take the parentheses, set it equal to 0, I call zeros, and then do the math. +1 + 1. So you end up with the opposite number of what's in parentheses. That's just a real fast and dirty way to do it. However, if I have a coefficient here, I can't just take what's opposite. All right, I gotta do a little bit of work. So opposite of what's in parentheses only works if that's a plain x. If there's a coefficient here, then I actually have to set it equal to 0 and work it out. -2, 3x equals -2, divide by 3, x equals -2/3. All right? When you get quick and fast with this, you can kind of do it in your head, all right? But just understand, if there's a coefficient here, I can't just take the opposite of this. Opposite of what's in parentheses only works if there's no coefficient. Got a coefficient, gotta work it out. All right? So, find the zeros. Factor, find the zeros. Do it on your own. So, GCF first. Always look for a GCF. In this case, -2. What kind of factoring is that? Yeah, fast factoring, or MA factoring. What multiplies to 6 and adds to 5? So there you go. So the problem just says find the zeros. I don't have coefficients to worry about, so the zeros are -2 and -3. All right? So this, I got a factor here. What's this going to be factored? So what are the zeros of this problem? Yeah, there's 3 of them. 1, 4, and -4. How can there be 3? Well, everything we're doing right now is graphing quadratics, parabolas, but that's not the only thing you can graph. This is actually called oh, the word's escaping me. Cubic, thank you. We're not going to get into this. There might be a couple problems for finding zeros, but we're not going to get into graphing this, but I just want to show you what it looks like. So this has 3 zeros. There's a 0 at -4, a 1, and 4. So this curve actually looks like that. All right, so it's a graph of a cubic, an x to the 3rd power graph. We're not going to graph those right now, okay? But understand they do exist. That's something you'll get into in Algebra 2. You might have a few problems about zeros that have more than 2 zeros, but we're not going to worry about graphing it. We'll just find the zeros. All right, so boom, boom, boom. Find the zeros of these 3 on your own. Pretty easy. Got a factor here, pull out the 3. So this, again, fast factoring, -2, x minus 2, that's a minus sign. So it's 2 and 2, it's double, it's called a double root. Perfectly legit. So here I got a factor. Told you that that method, that quick factoring of those perfect squares is going to come up a lot, all right? So this gives me a 1 and a -1. What does this give me? Well, I told you in the beginning, told you a little while ago, the way I find this, the way I can do opposite in parentheses, I actually take my factor and set it equal to 0. X minus 2 equals 0, and do the work. It comes out to be x equals 2. Same thing here. If I have just this, I set it equal to 0. Well, there's no math to be done. So that means 0 is one of my zeros. All right, so if you ever see a x out front, just a plain x, could be a 3x or a 4x, could have a coefficient, but there's no plus or minus with it, that gives you 0 as one of your factors, one of your zeros, or one of your factors. So, questions on this? All right, so now you use the zeros to make the graph. It's the same thing that we've been doing. Zeros and x-intercepts means the same thing. So I got to factor this. Fast factoring multiplies to -3 and adds to -2 is -3 and +1. Okay? So I know my intercepts, opposite of what's in parentheses, is +3, -1. When I write it like that, don't be confused thinking it's a coordinate point. I'm just listing them out. I should put braces around them. It should be placed. Okay. So once I have my intercepts, once I have my zeros, where do we go next? Yeah, I gotta find the axis of symmetry. So our axis of symmetry is halfway between. Add these two together, divide by 2. -1 plus 3 over 2 is 2 over 2 equals 1. So my axis of symmetry is right here at 1. Take your axis of symmetry, plug it back into the problem. So I've got 1 squared minus 2 times 1 minus 3, 1 minus 2 minus 3, -1 minus 3 is -4. So my vertex is 1, -4, the axis of symmetry, and the answer I got when I plugged in the axis of symmetry. So now I can graph. So that's the process for graphing. Again, find my intercepts. Zeros and intercepts means the same thing. Take my intercepts, add them up and divide by 2 to find my axis of symmetry. Take my axis of symmetry, plug it into the problem to find my vertex. Vertex tells me where that goes. Yes, you have to do this part, because we talked about it. I don't know the shape of my parabola. It could go like that. It could go like that. I don't know the shape of the parabola, so I have to plug in the axis of symmetry to find the vertex, to find the shape. All right? Do this one, graph this problem. Multiplies the negative 12, adds to positive 1, positive 4, negative 3. Get your signs right, or your signs will be off, okay? So my zeros negative 4 and 3. So I add those together. Add those together and divide by 2. So that's negative 1 divided by 2. So my negative 1/2. Plug it back in. Calculator come in real handy here. I'm going to get negative like 9, negative 10.5, I think. Grab a calculator. I think it's negative 10.5. So somewhere around there, we'll double check that in class with a calculator. But there is my vertex. All right. That's how you graph using factored. Questions, comments, issues? All right, get them out, get to work. We're going to review tomorrow, test Friday.